everyone, today I'll be teaching you how to find the LCM or the least common multiple. So what even is least common multiple? What does that mean? So least common multiple is just the smallest number that two or more numbers can all divide into evenly. So in other words, it's the first number or like the lowest number that shows up in the multiplication tables. So let's use the numbers 2 and 4. So what is the LCM of these two numbers? So to find the LCM, we can use the method of listing down its multiples. Like in the multiplication table of 2, that's just 2, 4, 6, 8, 10, 12, and 14, and so on, right? Because in our multiplication tables, there's 2 times 1, that's 2. 2 times 2, that's 4. We just listed it down. And then our next number is 4. And then we're going to list down the multiplication table of 4. So basically, that's just 4, 8, 12, 16, and so on. And we can see that in least common multiple, let's encircle the numbers that show up in both of these numbers. So these are the 4. There's also a 12, right? In least common multiple, we're looking for the common number in between, the common number that goes into the numbers evenly. But since it's least, this has to be the smallest number. So which one is the common number in between 2 and 4? That is the smallest one that would be distribute to it, or divide to it evenly. So that would be 4, because this is the smallest number. It's not 12. It is a multiple. 12 is a multiple, but it's not the smallest. The least common multiple is we're trying to look for the smallest number. Let's look at another example. We're going to try to look for the least common multiple of 4 and 6. Let's list down the multiples. So 4, we have 4, 8, 12, 16, 6, that is 6, 12, 18, and we can already see that we already have a 12 in our multiples, and that is already our LCM. But the problem with this method is that it can get really tedious of listing down all the multiples of the numbers, most especially if you have a really big number and you have to find the common number in between them. So it's important for us to find a way to get the LCM much faster without having to go through this. So I'm going to teach you guys a method on how you can find the LCM much faster. So I'll give another example. So for this example, we're going to look for the least common multiple of 6 and 9. So the first step on understanding this is understanding the concept of prime factorization. So prime factorization is just a method of making a big number into smaller numbers. So prime numbers, these are just numbers that its multiple is 1 in itself. So this is 2, because this can be broken down into 2 times 1. Its only multiple is itself and 1. Also 3, also 5, also 7, also 11, and so on. So let's make a tree here. We're trying to factor or prime factorize 6 and 9. So here, 6, what are the 2 numbers that can be broken down for us to get 6? That would be 2 and 3, because 2 times 3, that's 6. And since we already have 2 and 3, which are prime numbers, those are what we're going to use. Now let's go to 9. That can be broken down into 3 times 3, because 3 times 3 is equal to 9. Is 3 a prime number? Yes, it is. So we can already use these prime factors to find the LCM. I'll also use another example so you can further understand this more. Okay, so how about 12 and 15? How do we prime factorize this? So 12, what are the 2 numbers that can be used to get 12? So that could be 2 times 6. And because 2 times 6 is equal to 12. And is 2 a prime number? It is a prime number. Is 6 a prime number? No, it's not, because 6 can be further broken down into 2 and 3, because 2 times 3, that's 6. But how about if you thought of 12 and 4 times 3, because 4 times 3, that's also 12, right? Well, you can also break down this 4, because 2 and 2, 2 times 2, that's equal to 4. So you just have the same numbers as 2 times 6. So you basically just have to find the number that will break down the number. So it doesn't really matter on which one you use. For 5 times 3, that's just the two numbers that can be multiplied to this is 5 and 3, which are both multiples. So now let's focus on finding the LCM of 6 and 9, since I already explained the 12 and 15. Okay, now let's what is the LCM of 6 and 9? So what we can do is we're going to make a table. So 6 and 9. Okay? The factors that we got in 6 are 2 and 3. So we're going to write that down. Okay? 2, 3. Now, for 9, we got 3 times 3. What I want you to do is you have to line up the numbers, the same numbers with each other. So here we have our first 3. So we line it up with this 3 and leave this part blank because we don't have a 2. And our second 3, we're gonna put that 3 over here. We're not gonna put it over here because it's not 2, and we already filled out the spot for this one. So we're going to make another vertical one, and we're gonna put the second 3 here. The second thing that you have to do is draw a line, and you're going to bring down these numbers underneath this line. So 2, we're gonna bring down this 2. And then we're going to bring down this 3. So 3, that's just 3. And then we're going to bring down this 3, that's just 3 again. So we're not going to put these stacked ones, these are going to be quantified as one number only. And the next thing that we're going to do is we're just going to multiply these numbers together. So 2 times 3, that is 6, right? And then we're going to multiply 6 and 3. 6 times 3, that is 18. So this 18 serves as our CM for this question. So let's do another example. Okay, for this example, we have 3 numbers. That looks kind of scary, right? But no, don't worry about that. So we're going to break this down into smaller portions. We're going to make 3 trees. We're going to write the 2, 4, and the 6. So let's do prime factorization. So how many numbers? What are the numbers that are in 2? That's just a prime number. So that's just 2 and 1. 4, the 2 numbers that go into 4 is 2 and 2, because 2 times 2 equals 4. 6, the numbers that go 2 and 3, because 2 times 3 is equal to 6. The second step is to create the table. So we're going to write down the 2, the 4, and the 6. So 2 times 1, we can just write the 2 because we can eliminate this 1 over here because that's already prime number. The next one, our first 2 and 4, we're going to put it right here. Our second 2, we're going to make another space here. Then our 6, we're going to put our first 2 here. And then our 3, we're going to put it right here because this is not a 2. We're going to put it like that. So our main goal is just to stack up the same numbers, okay? So now we're going to bring down this 2. We're going to bring down this 2. We're going to bring down this 3. So 2 times 2 times 3, that's 4. 2 times 2 is 4. Times 3, that is 12. And that would serve as our LCM. Now let's use another bigger number. Okay, so our next question is we're going to try to look for the LCM of 12, 15, and 20. Let's write that down. 12, 15, 20. So the numbers that can be broken down to 12 is 4 and 3. 4 can be broken down to 2. So we have these prime numbers. Now 15, that can be broken down to 5 and 3 because 5 times 3 equals 15. And then this 20, this can be broken down into 10. And this 10 can be broken down to 5 times 2. And these are our primes. Now we're going to make a table, right? So we're going to write this 12, 15, and 20. So the prime numbers of 12 are 2. This is this one. And then we're going to write this second 2. And then we're going to write this 3. We didn't write this 4, okay, because this is not a prime number. This is why we broke it down into these two numbers right here. Okay, now in 15, we have a 5. We don't have any of common numbers here. And then 3, we place it right beneath this 3 here. Now our next one for 20, we're going to put the 5 over here, just aligning with the other 5. Our 2, we're going to line it up with this 2 right here. And then our second 2, we're going to line it up right here. Then we're going to make a line. My bad. We're going to make a line. We're going to bring this down. 2, 2, bring this down. 3, bring this down. 5. So 2 times 2 times 3 times 5. 2 times 2, that's 4, times 3 times 5. 4 times 3, that's 12. 12 times 5, that is going to be our LCM of 60. So that is just how you find the LCM of numbers.